All right, so now we're going to talk about graphs. We've already established that the logarithm is the inverse of the exponential. So let's start by graphing just a basic exponential, y equals 2 raised to the x. So if I graph that, let's get some numbers in a t-table here. Okay, so let's do -3, -2, -1, 0, 1, 2, and 3. So 1/8, 1/4, 1/2, 1, 2, 4, 8. So I'm going to graph those and just draw a general graph. Okay. So that is what an exponential would look like. Okay, notice that the domain is all real numbers, that you have a range of y is greater than 0. Okay, you can also think of it as a horizontal asymptote. Okay, so now if I do the logarithm, remember when you do a logarithm, you switch the x and the y. So if I were to draw the logarithm graph, I have a base of 2. Okay, what we're going to do is simply switch our x and our y. All right, there we go. Kind of hard to do with all the little fractions. Okay, so you can see here that they are truly reflections across the line y equals x. So let's draw that line in. Okay, so since they are inverses, your domain and range flip, or they trade places. Okay, and you'll notice that they are mirror images of each other. Okay, also notice that the base of our logarithm is never negative. So this number here is never negative. Okay. All right. Now, those same rules apply for transformations as they always do. So we'll try some of those in a bit. But this is just kind of a short introduction into the graph of a logarithm. So things to remember. Exponentials and logs are inverses. Okay. The common log is base 10. Okay, so sometimes we see that as this, but sometimes we also see it without the 10 written, so be aware of that. Okay? All right, so let's try some transformations. Okay, remember the rules for transformation still apply. So if I've got f of x is equal to a logarithm base b x minus h plus k, the a is going to control x-axis reflections and vertical stretches. And compresses, excuse me, or shrinks. All right, this right here will control left and right. This right here will control up and down. All right, so let's try a couple. All right, now, until you get used to it, I highly recommend that you always draw the parent function. Okay, so let's try one. I'm going to keep with log base 2, just to keep our life a little easy. Let's move this down a little bit so I can see it. Okay, here we go. Okay, so we're getting a vertical stretch by 5, and then we're going to move it up 2. So all of the effects are on the y. Okay, all right, so let's get a graph. Now again, you can always go to Desmos and check your graphs. Okay. All right, so I'm going to graph the original in red. Actually, let's redo that because that's kind of a bad graph. Okay, here we go. That's a little bit better. Okay, so move everybody up 2. Okay, remember these are sketches, so they don't have to be perfect. Okay, that's really bad. All right, there we go. That's better. Okay, so this is up 2. Now I'm going to do the stretch by 5. So let's choose another color for that. So if I stretch everything up by 5, that means my y values change, but not my x. So let's see, 2 becomes 10. And then 3 becomes 15, and I'm going to run out of room. And then 4 becomes 20. So let's see here. And I am definitely off graph. Okay. All right. In the next video, we will do some more. Okay.